Okay, so we can summarize this while the last people trickle in. Yeah, I mean, it's hardly worth repeating. It's clearly we can now write secure, we can be secure clients and servers, and I think going forward, there are going to be more and more opportunities or environments where you can take an APL component, a workspace with some clever code in it, and then offer it to people, in this form. If you had something available in this form that we had here, it's something that any programmer using Perl or PHP or VB or C# could call. It's a one-liner for him to call this function, right? And just to issue an HTTP request in .NET is a one-line expression. And to pass the HTTP, the XML or whatever that comes back in that is trivial. But let's look at a wrapping this stuff up a little bit more. Look more closely at this idea of service-oriented APL. So many APL applications, I think, are well suited to this. Most APL users know much more about writing clever computations than GUIs. So there's an opportunity here. So you can either just present stuff as an HTTP server, or you can use web services, which is what we're going to look at now. And it's a way of making IT managers more comfortable, and so on and so forth. And being a client of other people's services can also be very useful. So today, I think it's fair to say the most widely used mechanism for building service-oriented applications is the web service protocol. I think it started out mostly on Unixes, but has now become, the lingua franca. It's supported by anything that wants to use the web. So Wikipedia will tell you it's communications over a network using XML messages that follow the SOAP standard. SOAP was Simple Object Access Protocol, but I think at one of the recent standard meetings they officially decided to kill that idea, because it's not that simple. If we wanted to make this function call that we had before, well, here it is, get stats, and here's the input, and then there's all this stuff. But it's verbose, but you can learn how to format that stuff. Concatenating strings together in APL is not that hard. And to go with the actual function calls, there's a protocol called Web Service Description Language, WSDL, and it's also quite a mouthful when you look at these documents. This is a description of a service. It lists all the. I think I've got two functions here. There's getStats and there's APL exec. So I can make a call that executes some APL. But in order to describe all the variables that I'm going to use and so on, there's this huge document. You can see the scroll bar there is only about halfway down it. And we don't really want to know about that stuff, right? We've just got two functions or a function in a workspace, and that's where this tool that we've built called SOARS comes into the picture. So SOARS is for the Standalone Web Service Framework. Standalone means that you don't need IIS or Apache or something like that. An APL workspace can be a web service framework all on its own. And the idea is to make it very easy for APL users to provide these service-oriented components. So anybody who can write an APL function should be able to call existing web services and publish their functions as web services over the internet. And SOARS handles all of the SOAP and the WSDL. Generates it, chews it, and makes it go away from your point of view. So, in fact, there are a lot of public web services available on the internet, and you can Google for them, and I thought I would see if I could get a web service that told me about the weather. So I said weather web service in Google, and it said 495,000 hits. and I looked at a few of them, and I found one that had a WSDL that I could sort of understand. This one here, get city weather by zip. Of course, it takes American zip codes, so we can find the weather in the States. And so it's customary, if you have a web service, that you also provide a web page that people can go to that lists the parameters and shows you often the kind of SOAP that you need to provide to call it, because people are still learning about SOAP and how to format it and so on. So a lot of places you'll find, it tells you what the SOAP needs to look like to call this function. You can validate that what you're doing is correct. Though, of course, if you have source, you shouldn't care about that. So if you have source and you want to call this thing, you go, no, that's the one that doesn't work. You tell it the name of the IP address. Usually web services are simply hosted on port 80 like a web server, and the name of the page, and you make a call to the weather web service, the name of the function, and then a list of parameters and their names. And it gets hold of it knows how to format that, and it gets back a piece of SOAP with the results, and built into source is also something that will take SOAP and turn it into this structure here, which is a 3-column matrix, 4-column matrix. The first column tells you the depth of nesting of the XML at that. In fact, it's a general XML decoder that we're thinking about whether we should perhaps cover with quad XML, because we think this is actually a very useful way of looking at XML. You get the depth at that level, the name of the element. Stephen will correct me if I'm using the wrong terminology here. The value of that element, and then the attributes. So this thing here has an attribute called XML namespace, and that's that value over there. We don't care about that. We just want to know about the temperature and the wind. Yeah. And likewise, any APL application can be turned into a web service. Now, so you've got a function, and you need to provide a little bit more information describing your function, some declarations that source can use to build the WSDL that a client is going to want to, or may want to use to make the call, to build the SOAP to make the call. So you just need to provide some declarations, and source handles the rest. Let me see, I think I can do, I have a demo to do this, so rather than the foils, let me sit down and show it to you live. Okay, so let's not do that. That's just going to go to that web page that we saw. I don't know what happened here. Okay, so here's this call to the weather. 10:01. Is that New York City? Yeah. So the Wi-Fi is still working. Downtown New York. It's now 73 degrees and fog. And this is where my sister lives, in Seattle. It's only 49 degrees, but you can make any call to a web service if you just know what the arguments are that you need to provide. It builds the SOAP, it makes the call, and decodes the result. Yes.
If you require user code and password to use this web service, how does the web that?
Well, those will then be arguments that you need to pass to it, or it may be based on it being a secure socket, a secure web service, so that information is actually not passed backwards and forwards, but simply encoded in the, in your certificate. But very often there will be you know, if it's not a free web service like this, it'll be something where you have to encrypt a user ID and pass it along or have a certificate.
The web service that requires a user password.
Yeah.
Like when you're logging on a web page, how do you do that? I also have to have it.
Yes.
It would really depend on the kind of...
You get 401 back, and you then send back
Um,
the password.
okay, there may be a hole in my knowledge about web services here. Yeah.
Based on it could be based on, as you said, on software.
Yeah, so you might be alternating between using ordinary HTTP to do some stuff and then making web service calls.
It could also be based on the horrible WS extra protocols.
Okay, so there may be pieces here that we haven't built in yet that we need to add to this. Yeah. Okay.
I've gone through this process by hand,
Yeah.
so I'm guilty here. Yes.
Okay. Okay, so here's another one of these clever functions that, well, it's the same one as before. Wow, surprise. It's, there's lots of defuns in here. Must be clever. If you call this thing, yeah, we've seen that before. So, to make a web service in Source, you have to write a function called build API, and it has to return one of these 4-column things that corresponds to some XML. So it's we're telling it here that there's a method called getStat, so we're at level 1 there. There's an input parameter that's also at level 1. It's data type string and minimum 1, maximum 1. There must be one occurrence of that. And then there's a result structure called stats, which inside it has count, mean, median, and mode. And those are, let's see, single is this thing, minimum 1, maximum 1, ints and doubles. And then we concatenate that together, and that's all we need to do. So for each function that you want to expose, you need to write a few lines of code like this to describe it. And then you need to write a function which is also going to return one of these XML structures. So this thing called statCalc that we saw before appends the names of these things on top and then creates a header row which says 1 and the name of the structure, and then 2 and these 4 rows. So it creates an array representation of the XML stats result type. So if we call that thing, it returns this array form of an XML data structure. And are we going to trace that? Yeah. What this does is it then starts the web server. Well, actually, maybe I should trace it. Okay, well, it started the web server. The right argument of 1 says shut it down off when you're done and just run a test. So it started it on port 8080. It made 100 calls to the web server in 1.5 seconds. So it was doing 62 calls a second while being both the client and the server inside the same workspace. Everything going through Conga and back again. And then the results are all the same and look like that. If we call it with a 0, it starts it up and leaves it running. And we can now use the client, the call a web service method to call our own web service, which is now running in a separate thread in the same workspace. And it says trace me. Let's do it this time. I remember what's going on in here. So this is the call method. I suppose this is just to show that, okay, we called it here with I didn't make one of these proper XML things. I just gave it a 2-element vector, and there's code in here to say, well, if it's just a 2-element vector, then throw in the stuff to make it a proper 4-column XML structure, and then we make a client connection to the server, format the SOAP. Okay, so that's, here's the SOAP requests. There we are. There's the data. And then it puts on a little bit of HTTP stuff and the SOAP header, and sends that to the server using Conga. Waits until it gets block last. I went a bit too quickly there. There's a function to decode the SOAP request. If it decided that it hadn't received the full SOAP envelope, it goes back, does it again, until it's done, and returns the result. If we set trace, and when we make the call, it shows us both the result, but before that it shows the SOAP input that was received and the SOAP output that was generated. So if I now go to, okay, so this is just to prove that if you start another APL, whoops, which one is it? The other one. See, we are in source, so drc init quote quote, make the call. Yeah. And we can see again we got some output here in the session, so that made the call. Now, as part of source, it also provides this helpful web page that people will want to look at, that the developer may want to look at to use your web server. So if we launch Internet Explorer and point it to, you see all the stuff flashing by in the background there, and it says, oh, here's my web service, and it's got two functions. There's getStats and APL exec, and there's a formal service description, which is all of the, that stuff. Oops. What was it? Nope. Well, let's do that again. Where did that go? Should really open that in a separate window, shouldn't we? Okay, if I call one of these getStats, it checks the WSDL, or it checks the service description. It finds out, well, this takes one input line, and here's some data. It then makes the web service requests. Well, this is just Internet Explorer just responding to this HTTP page. It knows how to make the call and return the result, so that somebody who wants to use your web service can easily debug it using it, or find out how to call it from the from Internet Explorer. Okay, this would take us directly to the page that outputs the WSDL. We don't need to do that. We've seen it. Right, so now, if you were a C# programmer who wanted to use this thing, that's readable. You would need to write a program which looked like this. Let's see, where's the interesting part? Here, service.getStats something. So this is a command line C# program. You're just going to run it from the command line type getStats 1, 2, 3, 4, 5, 6. And the first bit here is looping around to collect what's on the command line buffer and put it into a variable called buffer. And then this gets hold of this is just a type declaration for the result. And this is, okay, my web service is new my web service. And then you just call it with that. If you get an exception of any kind, it just says I couldn't connect to the web service. If that succeeded, then this variable here is of type stats response, and it's an array of these. We know we're only going to return one, so the C# code then says, well, for the first one, give me the count, the mean, the median, and mode, and prints it out. So it's just a very simple C# program to call this. And if we go to the command prompt, what the C# programmer would then do, having written this, is he would call, let's see, what have we got here? We've got something called compile. Now what that does, it does two things. It first calls a program that Microsoft provides, and this would be the same, I think, in virtually, Eclipse would have an equivalent thing. Microsoft provide a tool called WSDL, which takes the URL of a web service, the page on a web service that returns the WSDL, and it creates C# code from the WSDL. So it's going to create a file called mywebservice.cs, which defines a class which covers your web service completely, right? Which makes that other C# code that we've written just work, because we then call the C# compiler with our program, and including this program, so all those declarations that made the get response stats be meaningful are included. So the C# programmer is told about your web service. He says compile. This then makes a request to the APL web server. You could see it there returning the WSDL. The delay there was not the web service responding. It was various bits of .NET being fired up. And it's now compiled it, and we can now say, what was it called again? Get stats. 1, 2, 3, 4, 5, whatever. And again, we're not waiting for the web service there. We were waiting for various other things to happen. I think if we do it again, it's not much faster. But we could do 60 of those a second when we were calling them from APL. So I'm not sure exactly what's going on there. So if you use web services, there are tools in virtually any development environment which make it trivial to use them, because there are tools which will get hold of a web service description and make it look like a class written in the language that the developer is familiar with or easily able to use. So this just turns your APL function into, well, in this case it turns it into a .NET component that a C# programmer can call. And I think that's the end of that. So okay, these foils here were just in case none of that worked. We've seen all this. Right. So SOARS provides complete support for what they call consuming and providing, or maybe that's not modern anymore. That's 2-year-old terminology. They may call it something else today. And you don't need to install any of this infrastructure. You can still do that if you want to. The problem with using SOARS, exposing it to the world directly, would be that if you were really attacked, then, Björn has there are some checks in Conga where I think if somebody just opens a socket to you and starts pouring vast quantities of data into it, you just shut the socket down after, after some amount of data has arrived without determination on the first connection. We just say, well, this doesn't look right, and close it. And we could put all kinds of checks into Conga so that it, You could put in a list of IP addresses that it should not receive data from, and so on. But that kind of functionality, of course, is built into these web servers. Some of them, anyway. The protection, against denial of service attacks is something that isn't there, and something that we might well build into Conga. If we have, customers who say, well, we really need that stuff, we'll build it in. Of course, if you're using secure sockets, you have some protection from that, because unless you get a certificate that's validated, APL never hears about it if you've set the flags to say, I only want to talk to somebody who has a client certificate that is acceptable. Then the C code that's in Conga will reject the connection before APL. APL won't even hear that there was an attempt to connect if you don't want it. Because if you want all the statistics and monitoring and management and so on, you might want to put one of these components in front of your product. And we also provide this web page that you'll also see if you define a web service in IIS. It'll also provide that web page which documents the this one here.
So Morten, just to clarify
Yeah.
that, so you're saying use, for now you might, if you want to go with a professional level,
Yeah.
you might plug that in with some IIS or...
I think if it were an outward-facing, if you really wanted to build a business with an, outward-facing web server, you either want to put one of these things in, or you want to come and talk to us and say, well, I need some form of hardening of Conga before you expose it. If you're using it internally in a large enterprise, it's still a very valuable tool, right? You don't need to protect against that stuff, I would hope, on your internal corporate network. And of course, if you're using secure sockets, then at least you know who's attacking you, and you can call the police.
Even internally, we're going to need capability, or one might need capability to scale. So forking that you talked about earlier,
Yeah.
that could be plugged into creating these patterns that you were talking about, listening
Yeah.
patterns, or whatever.
Yeah.
Very useful.
Yeah. So I mean, this is early days, right? We think this is really significant for APL. We think that it opens up or keeps a whole lot of opportunities open, because most APL programmers, I think, would really just write functions like getstats and then leave writing the user interfaces and so on to C# people or Java people. And this way, you can trivially do that. You could also compile your APL function into a .NET assembly, and that would have the same effect for stuff that's running inside the same machine. And of course, you can expose it as you've been able to expose APL functions as web services through IIS since Dyalog.NET, version 10.0, essentially. We provide sample workspaces to show how to do that with IIS. We've done that for years, but I think this is a much more straightforward. This is the kind of thing that your average APL person could just fire up and get running with straight off. Yep, it's there. So source is, if you want to play with source, ask us for it. It's not included in the product at the moment, but we're happy for anybody to have a copy, and I expect it'll be bundled with the next release. And I was expecting another bullet point there. One thing which I think we will now also do the work to turn into part of the product is a component which allows you to run your APL application as a Windows service. So something which, if Windows reboots, it gets automatically started by Windows. Because if you were running a web service, you would want that kind of...
Definitely.
Yeah. I mean, there are various ways to do that already. But the hardest part actually is that an APL application started in that way may not present a user interface, because that would be a security violation. So you need to build your own, or probably we will build some simple debugging tool to allow you to connect to a web a service that has crashed and see what's going on. Okay, so we have 10 minutes for questions.
Did you want to, could you comment again about the comparison of the array, the tree-based representation of XML that SAW's used, just having
Yeah.
the arrays versus just a generalized nested array, just store that. So that's the other way to do it.
Well, the representation that do we have one here? This representation that we have here is not a tree. This is a flat structure. It's only a tree because of these numbers here that tell you how the XML is nested. And so an alternative view of that would be to actually create a nested array which was a tree, so that this was, these twos were at another level of nesting. So you had a nested array that more closely matched the nesting of the XML. But I think that this is something that an APL application can much more easily work with. Having this just as a 4-column matrix and the nesting being represented numerically is something where you can much more easily write code to find stuff quickly than having to disclose and eat your way down what might be a deeply nested structure. So this would be something that would be useful to hear from people what they think. If we were to provide something called quad XML, where the argument which converted between this format, maybe there's no point making a quad function, just if you get SOARs, in fact there is an APL function to do exactly that, to map between XML and this format. But of course it's written, in fact, something like 50% of the CPU consumption of the framework is in those functions. Because this is not a problem that APL is particularly good for writing efficient code. It's good for writing code for, but not efficient code.
Can you show us the XML that
That generated? Oh, well, I probably can. It's there. It's one of these. Yeah, this is the result here, right? Generating XML is cheap. It's when the SOAP comes into the server and it needs to crunch it that's the expensive part. Yeah. Klaus?
How do you distinguish between value nodes and attributes in the other parent node?
Attributes are in the 4th column of that matrix. Yeah. Yeah, where did it? Oh, there's so much stuff here. Well, it was in the presentation, wasn't it? Yeah. There were no attributes there. There were attributes up here somewhere. Yeah, so we made so many requests to this thing in there we are. There's an attribute. There. Yeah. Yeah. So, I don't personally know enough about XML to know, whether this is complete, but this code was written for us by an external APL consultant who has quite a bit of experience in writing web services. And he says it's complete. I understand there's some issue with validation that may be missing. I'm not sure. I'll investigate that. Yeah. Alexei.
How is marketplace for web services at WSDL? Is it the same as DLL
The marketplace.
Yeah, you need something to shop for particular web service. Where should I go?
I go to Google, but I don't know if there's a more structured mechanism than that.
Or if
Well, let's try it. What do you want? What do you want?
It's a wonderful web service. What is the standard procedure to make it available to people?
I don't know if there's a catalog. Here we go, catalog web services. Ah! No, that's not quite it. Catalog.
I'm just good.
Yeah, I don't know the answer to that. Did you mean catalog of web services? Here we go. Web services catalog. Organized by financial domain area. Okay, well that's a company that's, I guess. So that's a company that's selling web services, which is something I think a lot of APL-based companies might. That's exactly what they would do, right? Here's a web service which calculates X. Yeah. So here's a company, integration so easy a sales guy could do it. Okay. So here's something, provides delay, market quotes, buy, try. Yep. Try, real-time quotes. Anybody interested in any particular shares today? Yeah. So I guess this is still an emerging market. But web services do seem, I thought until, a year or so ago, I thought web services were some sort of outdated technology that new clever Microsoft stuff was going to blow away, but it seems to be going the other way. They're becoming more and more, they're becoming the ubiquitous, the thing that everybody can do. Like ODBC right now is the database interface standard for Unix. Believe it or not.
Google had a web service, but they shut it down 2 years ago.
Yeah, they did.
Yeah, I'm not sure why. I think, what...
Like soap.
Sorry?
I think they didn't like soap.
They didn't like soap. I think if you were offering sort of fairly expensive services, you would probably say, well, there has to be a client certificate at the other end, and then you know who's at the other end. You can just count the calls and it's easy.